Here are a couple examples of simplifying expressions with square roots in them. So first let's start with one that just has numbers in it. So we're going to simplify the square root of 90. And the key as we do this is to always look for factors that are perfect squares. So to know what the factors of 90 are, we have to factor it. So since it's obviously a multiple of 10 because it ends in a 0, 90 factors as 9 times 10. And 10 also factors. 10 is 2 times 5. So looking at all of these factors, are any of these perfect squares? Yes, 9 is 3 squared. So the square root of 90, it's the square root of 3 squared times 2 times 5. Okay, now a key property of square roots is that if you have a product inside a square root, so the stuff inside the square root is all multiplied, instead of taking the square root of the whole thing, you can do the square root of each piece. So this is the square root of the first factor, which is 3 squared, times the square root of the second factor, which is 2, times the square root of the third factor, which is 5. All right, now square root of 3 squared, that's just 3. And the square root of 2, well, we can't really simplify the square root of 2, so we're going to have to leave that part alone. And the square root of 5, we're going to have to leave that part alone as well. So these two parts are going to stay the same. And rather than having 2 square roots around, we'll actually prefer to put them back together. So we'll put the 2 and the 5 in one square root like this. And of course 2 times 5 is just 10, so this is 3 times the square root of 10. All right, so taking a step back and looking at this whole thing, because we had a perfect square factor, we were able to get that part outside of the square root. The other factors, 2 and 5, that aren't perfect squares, they end up still inside the square root. Okay, so this is how it's generally going to work, whether we have numbers inside a square root or variables inside the square root, which is what we'll look at next. One quick warning before we look at our next example. So right here, to go from our first line to our second line, we use the fact that the square root of a times b is the square root of a times the square root of b. So great, that's true. It is a common mistake to pretend that this is true if you have a sum inside instead of a product. So if you have the square root with an addition inside, that is not the same thing as the square root of the first one plus the square root of the second one. So this is a really common mistake. Do not say that these are equal, because they aren't. Okay, let's look at our second example. So now we're going to simplify the square root of 24 times x cubed times y to the 4th. All right. And based on our experience from the previous example, we know that we can, since these are products in here, all of this stuff is multiplied together, we can look at the square root of each piece separately. So this is the square root of 24 times the square root of x cubed times the square root of y to the 4th. Okay, now let's deal with each piece separately. 24, remember we're looking for factors of 24 that are perfect squares. 24 is, let's see, it's 4 times 6. 6 doesn't have any perfect square factors, but 4 is a perfect square. So 24 is the square root of 4 times the square root of 6. Now let's work on the x cubed part. X cubed is not a perfect square, but x cubed is x squared times x. And x squared is a perfect square, so this is a step in the right direction. Y to the 4th is a perfect square. If you don't see that it's a perfect square, you realize that you can write it as y squared squared. Okay. Remember, one of the rules of exponents is that if you have an exponent to a power, and then in parentheses another power, those exponents multiply, so this y squared squared is y to the 2 times 2, which is y to the 4th. Okay. So the square root of 4, that's 2. Since 6 doesn't have any perfect square factors, it's just going to have to stay in that square root. So 2 times square root of 6. For our x's, we have x squared times x, so we can break this square root into 2 pieces. The square root of x squared and the square root of x. And for the last piece with the y's, we have the square root of a square. So that just gives us the stuff inside, which is y squared. All right, and it looks like we have one piece left that we can simplify, this square root of x squared. So 2 times the square root of x, square root of 6. Square root of x squared, that's x. If, we have to be a little careful, the square root of x squared is x if x is positive. And then the square root of x, right here, well, x is not a perfect square, so that x just stays in the square root, and times y squared. All right. If you want, so you don't have to do this, so this part's optional. If you want, you can take all of the pieces that still have a square root and put them together and sort of stick them at the end. Some people like the way that looks. So taking all the parts without a square root, we have a 2 and x and y squared. And then still inside a square root, we have the square root of 6 times x. All right, so again, comparing where we started and where we ended up, all of the perfect square factors ended up coming outside of the square root. So there's the 4, the x squared, and the y squared. So the perfect square factors came outside of the square root, and then the factors that aren't perfect squares, the 6 and the x, were still in the square root at the end. And that is how you simplify expressions with square roots.